Welcome everyone. We'll be discussing about the upcoming lab test. The lab test will take place on April 9th. So the lab test you will be given a mystery box, and in the mystery box will contain an electrical circuit, uh, consist of resistance and inductance or capacitance. So the mystery box basically has a RC or RL circuit, where the R and C capacitor could be in series or in parallel. And in case of RL circuit, the resistance and inductance can be in series or in parallel. So you might have four types of circuit: RC series circuit, RC parallel circuit, RL series circuit, and RL parallel circuit. So by observing the voltage and current wave shapes, you need to decide or find out how the circuits are built. So the circuit could be RC or RL, or in RC or and the inductance and capacitance, or resistance and capacitance, or resistance and inductance may be connected in series or parallel. And you also need to find the value of the component. So if it is RC series circuit or parallel circuit, you have to find the value for resistance and inductance. Also you need to find the value for resistance and capacitance. So let me start. So I would like to introduce you about the basic feature of oscilloscope. The oscilloscope is used to measure the voltage wave shapes and from or display uh, the oscilloscopes are used to display the time varying voltage. So here you might see most of the case oscilloscope has two channels, so channel 1 and channel 2. So you might see the channel 1 probe is here, channel 2 probe is here, and the channel 1 can measure the voltage. So you connect the voltage terminal with this port and grounded this port. So it is a two port probe. So you connect the voltage here and ground here, and also here you for channel 2, this side will go to the voltage and this side will be connected to the ground. So basically you see it is we connect across the terminal, not in series. So we connect this probe across the component, so we can measure only the voltage. So we connect this side with one terminal and this side with ground, so it is across the terminal or across the component. So that's why we can only measure voltage using oscilloscope. So if you wanted to measure current, so we just basically measure voltage across a resistance. And as you know, according to the Ohm's law, V equal to IR. So once you find the voltage, you will get the current. Current will be voltage over R. So for resistance, voltage and current are in phase. Voltage and current are in phase. So only there is a linear multiplication factor of R. So if you divide voltage with R, you can get the current. So that's why the voltage wave shape across a resistor is same to the current wave shape of that circuit. So that's why we measure current across we cannot measure current directly, rather we measure voltage across a sense resistor. So we call them a sense resistor. So basically the sense resistor, uh, usually a 1 ohm resistor, is used to measure the current through a component. So we measure or display the voltage across a component, and the sense resistor used to measure current through a component. Now look at the oscilloscope, the front panel and the screen or monitor of an oscilloscope. You see here, you'll see voltage per division. We said we can set this voltage per division. So there is a voltage per division knob here. So this is the voltage per division knob. So you can control voltage per division. So here you see the screen is divided vertically. So there are some axis lines or grid lines. This grid line shows voltage per division, and there the screen also are dividing it into some grids in the horizontal axis. These grids are called the time division. So you can find the time division in this axis, x-axis or horizontal axis, and find the volt division in vertical axis. So here, if you want to get the Vm, number of to measure the Vm, the maximum value of the voltage, you can find the number of vertical division for V peak. So if you know the center line here, then see how many peaks, how many divisions are vertical divisions to reach to this point. So let's say if it is a middle point here, so you see 1, 2 and 2.5 or 2.5. So that means there are 2.5 voltage divisions, and per division got this much voltage. So you can find the total voltage. So usually we can find peak to peak and divide by half. So for example, peak to peak is 1, 2, 3, 4 and half here 5. So 5 volt peak to peak times division divided by 2. And we also set time division. This is the knob for setting the time division. If you wanted to get the wavelength wider, you can set this, or you can make the wavelength narrower. So basically, how many cycles you want to say fit in this screen depends on the settings by you made from this time per division knob. So from this time per division knob, you can find the frequency of the wave. So frequency is 2 pi over t. T is a time period. So let's say it start from here. So you see how many divisions are up to this point, because the signal is repeating from here to here. So you see 1, 2. So there are 2 divisions. So you can say 2 divisions times time per division gives you the number of the time period t. So from this time period, you can find the frequency 2 pi over t, meaning this. Or you can find this mass is 360 degrees. From here to here is 360 degrees. So here will be 180 degrees. So you can find the phase angle from this time per division knob too. So how we can find the phase angle between two signals? So phase angle is the number of horizontal divisions between similar points of two waveform divided by number of horizontal division for a cycle times 360 degrees. So let's say one wave got 2 divisions from here. 2 divisions equal to 360 degrees. So you can find, you can use this to find the phase angle. I'll discuss it, how to find the phase angle, the next slide. So in this next slide, you can see how we can find the phase angle from between two waves. So let's say we have one wave here that is obtained from the channel 1 of your oscilloscope, and second wave is obtained from the channel 2. So channel 2 is providing me this wave, and channel 1 is giving us this wave. So from these two waves, so we can measure the amplitude the amplitude of the wave, and we also can measure the time period or frequency of the wave, and we also can measure the phase difference. So you see they are both waves. One wave start here, another wave start here. So the this wave is YA and this one is YB. So channel 2. You see channel 2, the zero crossing point for channel 2 is earlier than channel 1. So that means channel 2 is leading. Channel 2 wave is leading and channel 1 is lagging. And how much is lagging or leading, you can find from the difference between these 2 points. So if you think here, so you see for channel 1 or channel 2, both has same frequency. So there are 1, 2, 3, 4, 5, 6, 7, 8. 8 division. Sorry, 1, 2, 3, 4, 5, 6. 7, 8, 9, 10, 11, 12. So there are 12 divisions from in one period. So you got 12 divisions. So that means 12 division equal to 360 degrees. 12 division is equal makes 360 degrees. So you will get one division equal to 360 over 12. Now two divisions will make 360 over 12 times 2. So that means 60 degrees. So the phase difference between two signal is 60 degrees. So that means channel 2 is leading channel 1 by 60 degree. Now if channel 2 is a voltage and channel 1 is current, then current is leading. Let's assume this is voltage across the sense resistor, meaning that this is basically current and this is voltage. So voltage across the sense resistor is uh, assumed as a current because the voltage and current across the same sense resistor will be in phase. So we can say this is my current wave shape and this is the voltage wave shape, and here current wave shape is lead by the voltage by 60 degrees. So as you see the current is leading, so it must be an RC circuit, because RC circuit current is always leading the voltage. And if the opposite, that means voltage leads current, that will be RL circuit. So by observing the oscilloscope screen or oscilloscope monitor, by observing the signal on the oscilloscope screen, you can easily determine either your circuit is RC, capacitive circuit, or inductive circuit. For capacitive circuit, the current will lead, and for inductive circuit, the voltage will lead. So it is very easy to find this. Now let me find the expression of this voltage here, the voltage of channel 1. So how we can find the expression for channel 1 voltage? So to find the expression of channel 1, you have to see the maximum amplitude has two divisions, 1, 2 divisions. So we will get two divisions here. So for channel 1, let's say it is VB, has two divisions. So let's say two divisions, and there are each division has VA got two divisions, and each division has 50 volt. So 50 volt, so that will be VA equal to 100 volt. So 50 volt per division, so you'll get 100 volt. So you got the voltage from here to here is 100 volt. Now you have to find the time period. So what is the time period or frequency of this? So you see here, for here we have 12 divisions, so you can say t equal to 12 divisions, and each division has 5 milliseconds. So 5 milliseconds over division, so you'll get 60 milliseconds. So we are getting 60 milliseconds. Now frequency will be 2 pi over t. So you can, sorry, omega equal to 2 pi over t. Omega equal to 2 pi over t, so you'll get 2 pi and t equal to 60. So from here you can get the frequency 2 pi over t radians per second. So now if I wanted to write the expression for VA expression will be 100 volt, and let me write in terms of cosine, and this frequency is 2 pi 60 times t. So this is the expression for VA. Now if I wanted to find the expression for VB, the voltage across the channel 2 or across sense resistor, so VB will have 1 2 3 4 divisions, and each division got 0.2, so 4 times 0.2, 0.8, and there we write it in terms of cosine, and frequency is same 2 pi over 60 t, and the angle difference between this is 60 degree, so plus 60 degree. So this is your VB expression. As I said, VB is it has the same expression for current, so you can write current will be VB over R sense. So if you divide by the sense resistor, you will get VB equal to the current in the circuit or current across through the sense resistor. So IB will be VB over R sense. If you put R sense equal to 1 ohms, so you will have VB and IB got the same expression. So this is how we can find the voltage and current expression from the wave shapes. So if YB, we get YB across the sense resistor, so the voltage across the sense resistor connected in series with the black box, then we find the type of the load. So it could be resistive, inductive, or capacitive, depending the black box if the element in impedance of the elements are in series or parallel. So by observing the wave shapes, we can find the load, type of the load. So it could be RC or RL. We also can find how the elements are connected in series or in parallel, and we also can find the value of the black box component, so value of the resistance and value of the inductance or capacitance by observing the wave shapes obtained by the oscilloscope. So let us find take this wave shapes. I make the circuit clear so that you can easily get the message. So we'll need to find the so let me assume that we have a circuit like this. We have a circuit so we have a circuit and this is my black box, and this is my sense resistor, and this sense resistor got 3 ohms value. Now we connect our channel 1 here. So this is channel 1, and we connect my channel 2 here, channel 2 here. So let's say this is my YA and this is my YB. So we connect channel 1 at this terminal. So as you know, the channel 1, the one terminal of the channel 1 will be connected here, other terminal will be connected to the ground. For channel 2, one terminal will be connected here, another terminal will be connected to the ground. So now the channel B basically gives us the voltage across this resistor, and that will be equivalent to the current in this circuit. And channel A1 will give us the voltage across this. So voltage across the uh, voltage of the source voltage. So let me see how we get here. So we get a wave like this. If you see the oscilloscope screen, you will see, observe. So we'll observe a graph like this. So we'll get a wave like this. So we'll get the waves like this. It is not very good draw. So however, this is posted on D12, so you can see the graphs from here. So this is your YA and this is the YB. So this is basically channel 2, this is channel 1. So channel 2 gives this wave and channel 1 displays this wave. So now you have to find the, so what the values are given. So you have to, it is said that the box got a series component. So it is a, so it is a series, the components are connected in series. We don't know what type of components are they, but they are connected in series. So second thing it is, we have to find the value for the components. So how, what is the value of these unknown components here? So at first we need to find out what type of component are they and what are the values. So at first, let us find the expression for YA. So YA tells us the voltage across this, so you can write VA. So VA will have the voltage, so it got 2 divisions. So if you say the maximum is 2 divisions, so you can write 2 divisions, and the question says each division got 50 volt, so you'll get 50 volt per division, so that gives us 100 volt. So and for VB, the voltage in channel 2 is 1 2 3 4 4 divisions, and the voltage of channel 2 is 0.02 volt per division. So you'll get 0.08 volt. Now we need to find the angle, sorry, find the time period. So time period t equal to, so you see 1 2 3 4 5 6. So 6 is half half wave has 6 divisions, so full wave will be 12 divisions. So 12 divisions, and each division got 5 milliseconds, 5 milliseconds per division. So you'll get 60 milliseconds. Now omega will be 2 pi over t. So 2 pi over t equal to 60 milliseconds gives us 100, gives us 104.77 radians per second. So now you have VA is 100 volt, and if you can write in terms of sine or in terms of cosine, that doesn't make any difference. So if you write in terms of cosine omega t, so I write VA in reference, so it will be cosine 104.7 t. Now VA will be 0.08 cosine 104.7 t, and the phase difference. So you see the phase difference is 2 divisions. So you can find the phase difference phi. The phase difference is equal to 2 divisions, and each division got, so the total wave got 12 divisions. So 12 divisions has 360 degrees, and 2 divisions will be 60 degrees. So now we write 60. And if you look at this, we can also find the current of channel 1, channel 2. Current of channel 2 will be voltage over the resistance is 3. Sorry, unluckily I got, here we have 3 divisions instead of 4. We have 3 divisions, so I write it 3 divisions. So 0.6 volt, and this will be 0.6 over 3. So this will be 0.02 cosine 104.7 t plus 60 degrees. So this is my current expression, and if you look at this current and voltage, so current is 60 degrees leading by the voltage. So this component will be, so here we found voltage VA was 100 cosine omega t, and current IB, that was 0.02 cosine omega t plus 60. So current leads voltage by 60 degrees. So that means, therefore, so black box is an RC circuit. So now we got it is an RC circuit, and the question also tells the RC in series. So now how we can find RC values, R and C values. So to find this, you have to find the impedance equal to voltage over current. So here voltage, if you write in voltage the in frequency domain, it will be 0 degree, and current will be 0.02. So this is 100, 0.02 60 degrees. So you'll get 100 0 degrees and 0.02 60 degrees. So you got the impedance will be 5000 angle negative 60 degree. So this is the impedance in polar form. Now you can find in rectangular form. So now the polar so let me find the polar form of this. So that will be 5000 shift angle is negative 60. Now the rectangular form will be 2500, and the imaginary part is J 4.330, sorry, 4330 ohms. So we'll get the resistance is 2500 and the inductance is 4330. So if you have resistance, the total box resistance will be that this is the total resistance. So total resistance is box resistance plus the sense resistance. So the box resistance will be 2500 minus the sense resistance 3, so 2497 ohms, and Xc is this. So Xc equal to 1 over omega C. So C will be 1 over omega times Xc. So 1 over omega is 104.7 times C is 4330. So you can find it like on 104.7 times 4330 inverse. So it will be 9.5547 millifarad times 10 to the power negative 3 farads. So this is the value for capacitance and this is value for resistance. Now similarly we can find how the circuit components are connected. So how the circuit is built. If voltage leads current, the circuit will be inductive. If currents lead voltage, the circuit will be capacitive. And also we can find the series and parallel combination of the circuit. So to find series and parallel, I discussed the theory how to find a series circuit or a parallel circuit. So let us assume we have RC series circuit. So let us assume my black box has a R and C in series. So this is RC series. So to find RC series circuit, how we can determine my circuit is RC series circuit. To determine this, we measure the voltage and current, so that we already know how to measure the voltage across this black box and current in this black box. So to measure the voltage and current, and you also can find the impedance. So as you know, the impedance will be R minus J of Xc, or you can write R minus J 1 over omega C. So that means the R will be magnitude, the impedance will be magnitude of impedance and the angle of impedance in polar form, and the angle of impedance is equal to tan inverse 1 over omega c over r. So there is negative sign, so negative sign I can keep it down here. So it will be tan inverse 1 over omega r c. So we got the phase angle for the impedance. This is the phase angle for the impedance. Let's say this is in frequency domain. So now if I wanted to find the impedance using voltage and current, you can write the voltage impedance equal to voltage over current, and voltage can be written like the phase angle of voltage and current as a magnitude and phase angle of current. So now it will gives us the magnitude of impedance and the phase angle of current minus voltage minus phase angle of current. So from this you also can find phi z is equal to the phase difference phi v minus phi I. So the impedance phase angle is equal to the phase difference between voltage and current. So now this phase angle is basically proportional to the tan inverse 1 over omega rc, and this is equal to phi v minus phi I, or phase difference. Now if you look, if we increase the omega, then this angle will, this value that is phi z if you increase omega, that will phi z will decrease and phase difference will decrease. So let us assume that this is your voltage wave shape, and this is your current wave shape. Current is leading because it is RC circuit, and this is the phase difference. So now if you increase the frequency of the input signal, you will get the phase difference will decrease. So the current wave shape will move this direction. So if you increase the frequency, the phase difference will increase in frequency will decrease the phase difference. Between voltage and current. So that is for RC series circuit. So how I can determine it is RC circuit? By observing the current. If current is leading, that is RC circuit, and we also can find if it is RC series or not. So if we increase the frequency and see the phase angle is decreasing, that is RC series. Now for RC parallel circuit, So for RC parallel circuit, we can also find the impedance Z. So for parallel circuit, the 1 over Z will be 1 over R plus 1 over negative JXC, or you can write Y. The inverse of this is Y equal to 1 over R, and that will be J omega C. So now the Y has a magnitude Y and a phase Y, and phase Y will be negative tan inverse omega C over 1 over R. So you will get tan inverse omega RC. Now we also can find Y by dividing current by voltage. So current is such a magnitude theta I, and voltage such a magnitude at angle theta V or phi V. So you will get the amplitude, and the phase is phi V minus phi. So this is the phase difference. Phase difference. So from both equations you will get the phase difference, that phi Y is equal to tan inverse omega RC, and also equal to phi I minus phi V, equal to phase difference. So now if you increase the frequency, omega phi Y will increase and phase difference will increase. So for RC parallel, if omega increase, the phase difference will increase. So at first we should determine it is RC circuit, then we change the frequency and see how the circuit responds with distance. If the increase in frequency causes increase in phase difference, that is RC parallel. But if the increase in frequency decrease the phase difference, then it will be RC series. Similarly for RL, so if you see the RL, you need for RL circuit, RL components, the current will be lagging, current lags, and also if you increase the frequency, you will get increase omega and cause phase difference increase, that will be series RL, and increase omega, phase difference decrease, that will be parallel RL. So this is how we can find the configuration of the black box. So if you see current leading, that will be capacitive circuit. If voltage leading, that is inductive circuit. And if the frequency change causes the phase angle change, so you have to see how the frequency change affects the phase angle. So if the frequency change increase the frequency phase angle for RL circuit, then if the frequency increases for RL circuit, phase difference also increase, that is called RL series. If the frequency change causes the phase difference to decrease, then it will be RL parallel circuit. Similarly for RC circuit, if you see The frequency sense causes the increase in phase difference. This will be RC parallel. If a frequency sense causes uh, phase difference decrease, that is RC parallel circuit, RC series circuit. But the how and determining the value for R and C or R and L, we discussed before how to determine this. You have to see the maximum amplitude of the signals and the frequency and the phase angle, and using this information you simply use Ohm's law and you can determine the value of R and C or L. Thank you.